Hi guys, welcome back to SHKExcelWorld. I'm Salim Heather and we have been going on with our series on financial modeling with SHKExcelWorld. And this is the next part of the series. So there has always been a talk between the robustness of your financial model and how much close to reality your financial model is. And if you want to make your financial model too much real, and for that you will have to add extra steps and more complex calculations, then it may result in your financial model not being robust. But if you generalize your assumptions too much to make it robust, then you may end up having the wrong calculations. So at the end, there should be something which is in between the robustness and the reality. So in a previous video, we assumed a straight 8% inflation for calculating inflated replacement cost of the fixed asset for throughout the life of the project. So this was just for simplicity purposes, but we know that inflation rates are never stagnant over 10-15 years. But if you want to make your financial model real as well as robust, then you will have to do something which we are going to do today. So stay tuned, but don't forget to subscribe to SHKExcelWorld and give this video a big thumbs up if you like any of its contents. So guys, this is the file we are using today. This is the same file we used in our previous video, but you can download it from the link given below in the description. So this is a very simple table which requires us to enter certain data. One is inflation and the second one is the sales price increase, but at the moment we are only talking about the inflation rate. So the data type is percentage and we have to punch in the figure, and these are the green cells where we have to punch in the percentage of inflation, and it is saying that from year 0 up to a certain number of years, your inflation rate per year will be 8%. From 6th year onward, that is after the 5th year, your inflation rate will be 10% and so on. And after 10th year or from 11th year onwards, your inflation rate will remain at 5%. So this is our inflation assumption. And now we have to produce inflation rate for each of the years. And that should be based on a single formula. So this was a working where we assumed 8% rate inflation. So here we are going to use the help of index match formula. So if you are not aware of the index match formula, then don't worry, we are going to learn each and every bit here. But if you are aware of it, then you will probably connect with how I am going to implement the inflation rates for different years. So first we need to know how the index formula works, and then we will aggregate it with the match formula. Let us know the inflation rate. So here we are going to write the index formula equal to index, and the index formula now requires us to refer to a set of data or a table where our assumptions are lying. So we are going to go to our assumption sheet and refer this complete table, including the price increase. We will see how we are going to refer only inflation rate. So press F4 so that this table is locked, because this is the only table which is going to provide the inflation rate for all of the years. Press comma, and now we have to give the row number. So index formula requires us to tell about the row number. So I have written here, so this is the first row of the table, not the sheet. So first row of the table, second, third. So third row is the one which has our inflation rate. So we are going to write 3 here. We are telling formula basically that the formula should go into the third row to find our required data. And then press comma, and now the formula wants us to tell about the column number. So we know that our required information for year 1 is lying in the 4th column, which is 4th column of the table. So this is 1st, 2nd, 3rd and 4th. So we are going to write here 4 and bracket close. So it should ideally pick up this 8% inflation rate and bracket close press enter. So we just need to change the format of this value. So this is 8%, which is fine. So now if we copy it to the next cells, it is going to tell that the inflation rate is 8%, which is not correct. We know that the inflation rate continues up till the 5th year, and then it is going to change to 10% in the 6th year as per our set of assumptions. So for telling the formula that from 6th year onward you have to pick the 5th column of this table. So we have to say here that the column number now has changed, so it will be 5. So it's going fine up till the end of 10th year, but for 11th year again it is doing the same, that it is continuing the previous value, which is not correct. So we need something which can automate this column and row references. So for that, the only way out is the match function. So let us first try the match function and then we will add up both of these formulas. So let us go to our assumption sheet, and we can see here that the inflation rate is in the 3rd row of the table for all of the years. So we do not need to automate the row number. So the only problematic thing is the column number which we want to automate. So let us see how we can do this. So column number. So here we will write the match formula, match, and the lookup value is the year number, which is from the headings. Do not lock in anything because we are not going to copy it to any of the cells below. And if you want to lock in, you can lock in the row number by pressing F4 twice. Press comma and tell the formula about the lookup array from which it can find the year number. So the first row is not the one which has the year number, it's the second row. We'll have to give reference to the complete row of the table. We cannot do away with the first 3 cells. So in this way, the formula will know that which column number it is. If we start from the one which has the first year number, it will consider this one to be the first column of the table, which is not the case. So this is the 4th column of the table. So we have given the reference, press F4 to lock in the reference. Now press comma and now tell the formula about the match type. So it can be an exact match if you have something for each of the years, like for year 1, year 2, you have different things, then you can use the exact match type. But in this case, we have from up to a certain year number. So we can use the less than match type, and I will tell you as to what the formula is doing. So bracket close and press enter. So our formula is now locked and we can copy it to all of the cells and see what it is doing. So what this formula is doing, it is basically picking up the column number for all of the year numbers which are less than 6. Means from 1st year till 5th year, the formula is going to pick up this column, which is the 4th column. So it is returning 4 for year up till 5th. And then for all of the years which have a year number of less than 11, means from 6th year to 10th year, the formula is going to pick up the 5th column. And here we can see that it is the 5th column up till the 10th year. And for all of the years which are equal to or greater than 11, the formula is going to return the 6th column. So this is exactly what we wanted. So now we can easily copy this formula with all of its contents and go to the index formula and paste in place of the column number, because this is what we wanted to be dynamic. So paste it here and press enter, and now if we copy it to all of the years, so our formula should work pretty fine. We do not need this column number now. And here you can see that for up till 5th year, your inflation rate is now 8%. So this was the case in our assumption. From 6th year to 10th year, it should be 10%, and then afterwards, from 11th year onward, it should be 5%. So in this way, we have made our inflation assumption realistic as well as robust. So I hope now you have the actual tools to make this complex calculation very simple. See you in the next video. Till then, bye bye.